everybody, Dr. E-Blox here with the E-Blox project of the day. That's right, today we are going to learn about capacitors and how they are used. But before we get started, just a reminder, please stay at home. We're making these videos for teachers, homeschoolers, and parents so that they can teach the fundamentals of STEM and STEAM through E-Blox while safely from the home. Now, if you have E-Blox in your home, we encourage you to join in the building and learning fun. If you're looking to get E-Blox, there's a couple ways you can do it. You can visit our website at www.myeblox.com. That's www.myeblox.com. Or contact your local toy store. Call them, visit their website, or email them. You can buy products directly from your local toy store, but we'll ship them directly to your house so you never need to leave the home. All right, so let's get started with the project of the day. We're going to learn about capacitors. Now, if you have a Circuit Blox 395 or 800 set, you have some of these. We're going to look specifically at the 470 microfarad capacitor, part number 74. Now, a capacitor is kind of like a rechargeable battery. The way it works is it has a couple of plates in there, okay, metal plates, you can think of them like, and those plates are connected one to each of these studs. And there's some material in between called a dielectric, okay? But it's designed so that when you charge it, when you place a battery across it or provide power to it, it builds up electrons on one plate and it depletes electrons on another plate, which is kind of like storing power, storing energy, okay? And then once the energy is stored in here, then you can use it to provide power to other devices. So it is kind of like a rechargeable battery. So let's just see how it works here in a circuit. Okay, first we're going to build a circuit here that uses the transistor that we learned before that can be used as a switch. Okay, I'm going to put in this switch here, a little heart LED, okay, that's going to the emitter here. Okay, and remember when we provide a little bit of current into the base of the transistor, okay, which I'm providing a path here to do that, then that will provide a turn on for the switch to provide power through the heart. So now if I turn this on and I hit this, you see right now it's acting like a switch. I can turn on the heart, but as soon as I let go, it turns off. Now I'm going to take this capacitor, I'm going to put it in the circuit here, where now when I press this button, not only is it lighting up the heart, but it's charging the capacitor, so that now when I let go, the charge on the capacitor drives the transistor, and you can see the heart stays on for a while, right? Because once I let go, it's not the batteries that are powering that, it's the capacitor that's providing the power to the transistor that keeps the heart lit for a little while. So that's pretty cool, huh? So what are some of the applications of this, okay? Well, one, you can see it's kind of like in this circuit, it provides a delay, right? The lights stay on for a little while. Let's think about that. Where have you seen that before? Maybe in your house, you turn off some of your lights, but they stay on for a little while so you can get out of the room. Or definitely in your car. A lot of times you turn off, your car and you get out and the lights are still on. They stay on for a little bit and then they go off. You could use a capacitor to keep them on for just a little while and go off with a delay like that. But also just the storage, the power storage. Like if I take this heart out now, and now when I push this button, I'm charging the capacitor, okay? But there's nothing for it. Actually, I have to take this out of here. If I charge this capacitor, okay? Now it's being charged, but now there's nothing for it to discharge through. And so I can take it off of here, leave it over here for a while. I'll hook this circuit back up, okay? Been a while, I've left this thing, okay, but now when I put it on here, it kept its charge. It stored the power until it could discharge through something. So even though rechargeable batteries in a lot of cases have been less expensive than using capacitors to maintain power and storage, there are some applications for capacitors, particularly supercapacitors. In certain instances, it may not be just the cost of the device, it may be the maintenance of the device or the environment that the device is in. So for instance, you ever see those wind turbines that are out there? And they generate power, but we don't always have the need for the power right away. We want to store it. But now that requires a big super capacitor to store. But if I use the rechargeable battery in that case, rechargeable batteries, they start to deteriorate and don't work as well. If you charge them up and then discharge them a lot, they don't work as well. You can actually get a capacitor to last 2 to 5 times longer if you're charging and discharging it a lot. And then also capacitors will work more reliably in the very hot weather and the very cold weather. Okay, so they're actually starting to use some of these supercapacitors to store power for those wind turbines or even solar panels, or sometimes even in the car it works well with a battery and a capacitor to provide maybe some more power for your loudspeaker. So those are some cool applications. You know, I was at the store the other day. I was going to buy a capacitor, so I got it, brought it up to the desk, and the guy asked me if I was going to pay cash. He said, "No, charge it." All right, well, that's it for today, folks. But you're not going to want to miss the next time because we're going to build our own working alarm clock, okay? But until then, stay home, stay safe, but continue learning with E-Blox.